Now, this is the best part of today. Conditional probability. We're almost done. I'm about to wrap this up, I promise, okay? Conditional probability is probability, basically, something is said dependence. It's all about dependence. Ultimately, I'm going to be completely honest with you. Conditional probability is when you're shrinking, this is important, it's usually a story, you're shrinking, for one reason or another, your sample space. So the top number, in a manner of speaking, stays the same, right? Remember how probability of something was some number of an event over some number of a sample space, right? Well, conditional probability takes this sample space and makes it smaller, okay, by some condition. Okay, let's take a look at this. Find the probability of randomly selecting a member of the band from all students. Now, this is a Venn diagram. Learn how to read them. How many students do we have? Well, we got 45 in this pocket right here. We got 5 right here and 15 right here. Let's see, I do some quick math. 50 plus 15. I think we have 65 students right here. So, sample space is 65. Easy. How many are in the band? Now, careful, don't say 45. 45 is wrong. How many are in the band? 50 of them are. 50. These are band people, and these are band geeks as well, who apparently have no life because they're somehow in the student government as well. Okay? There are 50 people in the band, just like there are 20 people in student government. Learn how to read these, okay? That's it. That's the answer. You can reduce, but I don't really care. Find the probability of randomly selecting a member of the band given, huge right here, that they are also in student government. So these students are also in student government. So the probability, so we still think about, okay, a couple things are different now, right? Our sample space is not the same. We are talking only, this part comes after the given. Let me actually rewrite this. This is probability of band. They're in the band. This is probability of band, and then understand this notation here, given government. Okay, probability of band is 50 out of 65. Probability of band given they're in the government, well, suddenly our sample space is just the student government. We know they're in student government, so all of these people right here, they can take a hike. How many people are in the student government? Well, exactly 20. There are 20 people in our sample space, 20 people in student government. How many people are in the band of those 20? 5 of them are. Now, what we learned from this is that being in student government makes it less likely for you to be in the band. 1 out of 5 is a way smaller number than 50 out of 65. Being in student government makes you less likely to be a member of a band, which in context might make some sense. People in student government may have less time to be in band. All right, let's examine a bigger problem. I love these, by the way. So here we've got a table, some people in the after-school math club. These are not real numbers, although our numbers aren't terribly far away. Although we need way more girls. Our girl numbers aren't near this much. Girls, join math team. Okay, so what we've got right here, we're talking about some probabilities here, okay? We're picking people at random. Look at how these are written, okay? What's the probability of choosing a girl given, that's this symbol right here, given that this person is also a sophomore? So we're only looking in the sophomore row. You understand? We're only looking at sophomores. Juniors and seniors do not count. How many sophomores do we have? Well, I might add another row right here. We'll call that row, it's got a total number of 23. 23 sophomores. So our sample space is 23. And then how many girls do we have in that sample space? Again, that's my desired outcome. We've got 10. 10 out of the 23. Not 10 out of the total number, okay? All right, let's take a look at the next one. How many are a junior given that they're a boy? So boy puts me in this column. How many guys do we have here? Let's see. 17 plus 5, so 22. So we've got 22 guys in math team total. What's the likelihood that we choose a junior? Now, we're not going to count these juniors, right? And we're not going to count, obviously, these seniors. None of them are even in the group we're dealing with, right? We're just dealing with the right column. So what's the probability of choosing a junior given that they're a boy? Well, let's see. 4 juniors out of the 22 boys right here. This is simple. It's pretty straightforward, but I hope it makes some sense.